Each survey instrument has its good and its bad parts, and are each used for different applications in the surveying process. Every construction project and every map starts with a survey. George Washington was not only one of our first presidents, he was also one of the first surveyors of the United States. My name is Kevin Lindsay. I'm a staff sergeant in the United States Air Force. Part of my job as an engineering technician is to do different surveys for the Air Force, both construction surveys and mapping surveys. Today, I'd like to walk you through 3 different surveying instruments that we use in my day-to-day job. I'm going to start out first with the oldest piece of equipment that we use, the Surveyor's Transit. The Surveyor's Transit, it measures both horizontal and vertical angles. It does not measure any distance. It only measures an angle up to 1 minute, so its accuracy is a little bit off. At 1 mile, the angle accuracy to 1 minute is 1.5 feet. So for 1 mile angle, you're going to be off 1.5 feet. Not accurate enough for most surveyors. It takes a lot of calculations once you get out of the field to figure out exactly the information that you need when you're mapping out different features or mapping out different calculations for construction projects. The Transit does not take any batteries, which makes it a valuable tool for us. When we're out in the field and we aren't around a power source, we can still use the Transit. The Transit used in different surveys. It can determine relative positions of both points, lines, and objects on the Earth's surface for making maps. It can also help you determine the height and grade of different construction pieces, such as foundations for buildings or drainage for a ditch on the side of a road. This is the Transit right here. As you can see, it's got a telescope that moves both vertically and horizontally. Has a compass right down here in the middle. And it's got a plate down here where you can read your horizontal angle and also a sight to read your vertical angle. Pretty simple tool. Next tool I'd like to talk about is the total station. Today I'll be using the Trimble 5605 as my example in a total station. A total station measures horizontal angle, vertical angle, and distance, and it is extremely accurate. At a distance of 18,040 feet, the total station is within plus or minus 3 millimeters of its actual location. So, what that means is at 18,040 feet, if you're taking a shot that far, it's going to be within about that much. It's a pretty cool, accurate tool. The total station also is completely electronic. It does all your calculations for you. You can download your data from the field into a computer and pull up everything. There's no mathematics involved. It kind of takes away that human mathematical error. The downfall to the total station is it takes batteries. Sometimes out in the field, your batteries are going to run low, you don't have a place to charge them. So that's the only downfall. You're limited by the battery life as the length of your survey. Total station is also used in the same applications as the Transit. It can map out points, lines, and objects on the globe, and it can also be used for construction, getting heights of foundations or grade for ditches or even grade for roads. This is the 5600 made by Trimble. Again, it has a telescope. It tilts this way, spins on an axis this way. It's really easy to use, really easy to set up. You talk to it through this data collector. This is your interface with this instrument. It's just like a handheld computer, basically. It has special programs on it for different surveying applications. And that's the total station. Very accurate, very useful tool. The last surveying instrument that I'd like to talk to you about today is the GPS surveying system. GPS surveying system that I'll be using for this speech is the R8 made by Trimble. GPS surveying system does not measure horizontal angles or vertical angles like the other 2 surveying systems I showed you. It measures angles and distances between itself and satellites that are in orbit above the Earth. Its accuracy isn't as great as the total station, but it's a lot better than the Transit. For a horizontal accuracy, the Trimble R8 has a horizontal accuracy of plus or minus 8 millimeters and a vertical accuracy of 15 millimeters. So what does that mean? It's going to give you a horizontal position that is plus or minus 8 millimeters, and a height position on the Earth's globe, your elevation, is going to be plus or minus 15 millimeters. The GPS system also does all your calculations for you. All you got to do is download it to a software program on a computer, and all your data comes up already populated. Again, takes away that human mathematical error. There are a couple downfalls to a GPS system though. The GPS system needs a clear line of sight to the sky, so no surveying around big buildings, no surveying in woods, no surveying on rainy days. You're just going to lose a lot of accuracy by surveying in those conditions. Also, the survey system has a small lithium battery. Usually it only lasts about 4 hours. So you don't have a lot of surveying time with it unless you have multiple batteries that you can keep replacing and charging, and you get into that war of batteries. This right here is the Trimble R8. It's on a 2-meter pole so that it has a clear view to the sky usually. This is your satellite receiver. It receives all your information from your satellite. Again, you're going to use this handheld data collector to collect all your data and to interface with the receiver, and then download from here into your computer. And those are the 3 survey systems that we use in the United States Air Force for our different types of surveying as engineering technicians. I hope that you've learned a little bit about the transit, the total station, and the GPS system, what their capabilities are, what they're good for, and what they're not so good for.